Good morning and welcome to the Trusted CI webinar for December 7th, 2020. I'm your host, Jeanette Dopheide. Trusted CI is the NSF Cybersecurity Center of Excellence, and these webinars are part of its mission to deliver high-quality, actionable guidance regarding cybersecurity to the NSF community. More information about Trusted CI can be found at trustedci.org. Today's topic is a panel hosted by the Trustworthy Data Working Group to discuss tools, standards, community practices, and other things for trustworthy scientific data sharing. Our panel is led by Trusted CI Deputy Director Jim Basney, and we have a great group of guests that will introduce themselves once we get started. Before we begin, I have a few things to remind everyone about. First, this presentation is being recorded. Participants are welcome to ask questions during the session, but we also are planning on having time for questions for the attendees as well. So Jim will help guide that portion of the presentation. And let's get started. Jim, welcome.
Thanks, Jeanette. Hi, everyone. And so if we move on to the next slide, we'll see our distinguished panelists listed with their affiliations. So I'm really pleased to have Sandra, Robert, and Rebecca join us today. Sandra from the University of Notre Dame, Robert from NIST, and Rebecca from Research Data Alliance US. And so the way this panel is going to work is that the four of us will give some introductory remarks, and then we'll leave the bulk of the time for discussion. And so I will act as panel moderator. I have some questions for the panelists. I expect the panelists will also have some good questions for each other, but I hope also that you attendees will have some questions for the panel. So please be bold and ask your questions in the chat, and then we'll try and do the Zoom magic to unmute you and so that you can ask the questions directly of the panel. And so without further ado, let's begin our introductory remarks. And so the next slide will have some introduction to the Trustworthy Data Working Group that I've been chairing over the past year. And so you see listed alongside me many of the members of the working group who contributed to our most recent report, guidance report on management of trustworthy scientific data. And you see affiliations of many of the participants. So we've had a really nice broad participation in this trustworthy data working group from not just Trusted CI, but other NSF projects listed below. And I'll also please note the homepage for our working group where our materials are located. So on the next slide, I will give a short summary of our survey report. So the working group conducted a survey in April and May of this year, and we received 111 survey responses. And you see the breakdown of who responded to the survey over on the right there. And so we did get a lot of good responses from research computing facilitators and infrastructure providers and operators, along with science users, science data users, scientific data creators, et cetera. And so some findings from our analysis of the survey responses. One was that a common definition of trustworthiness for scientific data was somewhat elusive, although you see in that second bar graph, integrity and reproducibility were the most commonly selected attributes that were important for trustworthy data. About 90% of the respondents agreed that trustworthiness of scientific data is important, though interestingly, only 69% felt that trustworthiness was part of their job duties. And so I think one topic we could discuss as a panel is who's responsible for the trustworthiness of scientific data. We had some open-ended questions, and in terms of concerns about trustworthiness of scientific data, some concerns that were indicated in our response were impact on scientific results, reputational risks, and generally how trustworthiness of data impacts the integrity of the scientific process. We also asked a question about interest in guidance about trustworthiness, trustworthy management of scientific data. And in general, the respondents were open to additional guidance, especially guidance about where to start and how to prioritize different aspects of data trustworthiness, because of course there's a lot of guidance out there, and so we don't want just to add to the all the overwhelming amount of guidance, but give the researchers and the broader community a way to navigate that guidance. And so there's the DOI for our full report on the survey results, which you can also find on our homepage. And then on the next slide is the key findings from our guidance report. So since we did have that response that people were interested in guidance, we thought about what guidance to provide to the different stakeholders that responded to our survey. So scientific data users, data providers, infrastructure providers, research facilitators, and also security and compliance professionals, and how to help them address barriers to trustworthiness of scientific data that can include conflicts between security and reproducibility. For example, applying software patches can change the version of the software you're using and may lead to challenges reproducing scientific results. Accidents can disrupt your scientific data. Lack of funding and incentives can make it difficult to implement a lot of best practices around data trustworthiness. And also, the original quality of the data that you collect can impact the overall trustworthiness of the data. We found in our survey real good tools for providing your data in a high availability manner so that the integrity of the data is well maintained, and the authorization, the access controls around being able to access the data can be implemented. So we found good coverage there, but we also found a need for stronger support around managing data authenticity, confidentiality, and reproducibility. And I think we'll hear from our panelists on some of those topics. Also in our guidance report, we talk about how to communicate the trustworthiness of your data. And two aspects that are really key there are the metadata associated with your data that can communicate the provenance of the data, and also how to communicate the policies and other trustworthy aspects of the data repository holding the data. And that can include certifications around the practices of that data repository. So there's the DOI for that guidance report, and again, the URL for our working group that has those two reports and other materials from the group. And so that's my quick overview, and now I'll turn over to our next panelist, Sandra, to give us some intro remarks.
Thank you. Yeah, I'm Sandra Gesing. I'm from the University of Notre. I'm part of the Center for Research Computing and part of the Science Gateways Community Institute and PresQT, the Preservation Quality Tool project. So that will be the main topic of my talk. And I'm also a co-PI on the US Research Software Sustainability Institute and the steering committee for the US Research Software Engineering Association. And I lead an interest group at RDA. So Rebecca later will talk more about RDA. So I will make that part short. And I mention all these projects because they have some commonalities. They all have to really work. Oh, it was fine. Go to the next slide, yes. They have commonalities. So it's about that data sharing. It's we need to create data in research because we need to find data again, to also show results, to publish the results, to know the provenance, and of course also security. So there are a couple of different standards like HIPAA for health data or student data. So it's really important to have a sharing and preservation ecosystem, and the user is in the middle of it. So if we look at these examples, Hotel, Hub0, and OSF are science gateways, or we call them also virtual research environments or virtual labs. So virtual research environments are often used as a term in Europe and virtual labs in Australia. And what they deliver is you can share data there. You can share projects. You can have really also something like starting of simulations. So that is the definition of science gateways, how we look at it. Next slide. And but the goal of science gateways is really to share, to publish, to do research, to make research easier for researchers. And repositories have a different goal. So they're really there to have, in the long term, access to the data in the best way, in a curated way with a lot of metadata already. And you see here examples like Zenodo, GitLab, Figshare. I'm sure you heard about it. These are all partner systems we are working in PresQT already with. Next slide. And there are also services. So you might have heard about SciGraph for enhancing keywords, or FairSharing.org or FairShake Cloud. So they're really implementing already suggestions how to make data more fair. And PresQT is working with these services and using them to improve the quality of data and information of research data. And EASY is also a fantastic project. It's an emulation service. So you might have the situation, for example, you have Excel spreadsheets from 20 years ago. So you cannot open them anymore because you don't have access to the software anymore. And EASY has solutions for this kind of problem. So they created really the emulation services. And if you send your data there, they bring you back whether they have already a service for it to show you the data, and you can save it in a format that you can use on your own computer. Or yes, they bring back that this might be not a service they have at the moment for this format, but you can contact them. Next slide. And PresQT is in the middle of this, all the stakeholders and projects. So it's a boilerplate to connect them all, because so users, let's say the researchers, like to work in their science gateways. Of course, a lot of researchers also see that they have the need for repositories to save and store their data in the long run and to curate it. So how to get it really in a nice way, in a fluent way, in the different system. And PresQT is an API and offers services to connect all these different systems. And in the systems, then you use the services in the background. Next slide. So the PresQT project has a couple of different stakeholders, like the domain researchers, data curators, repository managers, librarians, software developers, workflow tool developers, the linked data community, and journals. And I just read this really from the graphic because we had a survey at the beginning of the conceptualization of the project, and 1,740 people answered the survey what they think, what they need to increase data and information, and also about trustworthy data. And then we developed the concept for PresQT and implemented it. So it's not a standalone solution. The partner systems and services can easily be integrated via standard APIs. So we are using RESTful APIs. It's a user-centered, open designed and collaborative development. So everything is in GitHub. Everyone can contribute. We have every 2 weeks user meetings where you can contribute with your ideas and also suggest further tools for PresQT. So we have keyword enhancement. We have the fair testing, the connection to the fair testing tools. We check fixity with the transfer between different systems. And if you look at the graphic, we are at the moment at the QA testing phase. And we are happy, everyone who wants to try our services, we have a demo UI where you can see what the PresQT services are capable of. And the next step is really also to show the users always a JSON information, because and that comes back to the trustworthiness. Every step that has been done by a PresQT is also recorded in a JSON file. That means if you transfer one file to another system, it will be, the metadata will be transferred with the file. Or if you enhance the keywords, if you do the fair testing, everything will be safe with it. And that goes back to the aspect of provenance, but also to trustworthiness in a way to see where the data comes from. And not only where it comes from, but what additional metadata was added via the PresQT services. And that's from me for the moment.
Okay, so I'm Bob Hanisch. I'm the director of the Office of Data and Informatics at NIST, the National Institute of Standards and Technology. So next slide, please. One thing I'll talk about in terms of trustworthiness of data is a collection of data products that we host in my group at NIST called Standard Reference Data. These are the most highly reviewed and vetted data products that we produce at NIST. And this data collection was started officially in 1968 when Congress passed the Standard Reference Data Act. And this suggested that the Department of Commerce, of which NIST is a bureau, should establish this collection of data in order to support US industry and research with data that was highly trusted. We now have some 65 databases, most of which are freely available, but others actually one has to either subscribe or pay an access fee. And that was kind of a shock to me when I came to NIST 6.5 years ago, that we should have government agencies providing data on a cost basis. But basically it is to recover cost of maintenance and distribution of the data. We sell around 6,000 units of these databases per year, mostly as downloads, but also we have agreements with distributors and vendors of instrumentation who embed these databases into their instrumentation. And the best known case of that is our mass spectro library, which gets embedded in essentially all vendors' mass spec devices that are on the market. Our most widely used, no, not yet, go back, there, yeah. Our most widely used database is our chemistry webbook, which gets as much as 2 million views a month. It's used widely by educators and students and researchers around the world. But we also have somewhat more esoteric data, such as this X-ray photoelectron spectroscopy database that still gets as many as 300,000 views a month. Do I want to say more about standard reference data? I don't think so. So going on to experience that we have at our Thermodynamics Research Center, which is based in Boulder, Colorado, they have agreements with a number of journal publishers to review data submitted in articles. And they have a number of heuristics they run in order to identify if data are not being well characterized, if there are problems with uncertainties, even if there are just typos in data tables. And it's really quite remarkable that of these 6 or 7 journals, which we have partnerships with, in fully 50% of them, there are data reporting problems that fortunately are identified prior to publication. One of the biggest problems that is encountered is that uncertainties are very poorly characterized or are seriously underestimated. In those journals that we work with in collaboration, after the NIST review, the rate at which erroneous data is published is down to around 0.5%. But for other journals that we look at and also ingest data from, the error rates are much higher, typically 5 to 6%, but in some journals up to 25%. So there's a serious issue with data integrity and trustworthiness that comes from inadequate review of data content in many research publications. going forward. So some observations I have about how to improve trust in data. One is that organizations should have some sort of rigorous internal review process to make sure that data that is being published has passed muster, and at least a very big concern for us at NIST is uncertainty characterization. That review should be impartial. It should be done by people who are familiar with the field but are not vested in the outcome in getting the paper published. One virtue of increasingly open data and fair data is that it becomes much easier to make comparisons between data sets and expose those that have poor quality. And as I just mentioned, our Thermodynamics Research Center experience, where we have collaboration between domain experts and publishers, leads to much higher quality data being published. We also need to extend our capabilities in domain-based data repositories, where data experts can contribute to data quality through knowledgeable curation. My experience prior to coming to NIST and managing the Virtual Astronomical Observatory, in that case, we really relied on what I call reputation-based data quality. The community in astronomy is small enough that people know who can be trusted in their data publications and who needs to be more carefully scrutinized. It turns out this also pertains to much larger research fields such as materials science, where again, reputation is paramount in terms of determining who is producing trustworthy data and who is not. And ultimately what we need is full transparency of the research data record, not only the data, but the software and the methods, in order to improve the multiple R's in this space: reproducibility, repeatability, replicability, and rigor of research data. That's what I have to say. Thank you.
Hi, I'm Rebecca Koskela, and I'm going to talk about some different projects, more on a project base and cyber infrastructure security. Next slide. So the first project I want to talk about is a NSF funded project that aggregated environmental data. DataOne was funded for 5 years, and then following another 5 years. But in the first 5 years, the work for this project was done by 11 working groups. And one of these working groups that was there from the very beginning was a federated security working group. And the idea behind this is, without trusted data, it's hard to have a community that will use your services. And trust requires security and reliability. During the first 5 years, DataOne had the Center for Trustworthy Scientific Cyber Infrastructure do an audit of the architecture and the services they provided. And this actually helped a lot with the funding for the next 5 years, because this had been built in from the very beginning of the project. And because of the audit, we actually had an external source that could certify how security was built in to the DataOne project. Next slide. So the Core Trust Seal cohort was something that was funded through a grant from and AGU in order to, the cohort started out with the EarthCube Council of Data Facilities. And what the cohort did was to bring together different repositories so that they could share information as they applied for the Core Trust Seal. In addition, it also paid the fee that is necessary to submit an application. And what we found out by having this cohort together, it is extremely, it's nice to have people to talk to about their experiences in going through the Core Trust Seal. Core Trust Seal is, even if people don't submit the application, by going through all the different aspects, and one of these is security, is it allows the domain repository to actually check to see that they are paying attention to all the things involved in a certification. All of the aspects of the Core Trust Seal guidelines don't have to be done, but you have to be able to document where you are, whether you're aware of it, you're planning it, or it's already in place. So one of the things with NSF funded repositories, it's becoming, the repositories, when they're recompeted, they're more successful if they actually have Core Trust Seal certification. It's another item in their favor. Next slide. So Research Data Alliance is a global organization that works on building the bridges, both social and technology, to make data reusable and shareable, findable, essentially fair. There are many different groups in the Research Data Alliance that are working on security. It started all the way back in the plenary 3 in Dublin. And that was the focus of that plenary, was actually what is needed to have a data sharing community. And there were groups that got started at this plenary on fair data and trust and security. Sandra is the co-chair of the virtual research environment, and during their meetings at plenaries, security is one of the things that they talk about. And actually, the Core Trust Seal is a product of Research Data Alliance. It was put together, the idea for the Core Trust Seal was put together by an RDA World Data System Working Group. Other groups that deal with security and trusted data are the sustainability of e-research and cyber infrastructures. And there's a data fabric interest group. In addition, the domain repository interest group came up with the trust principles. And the trust principles are transparency, responsibility, user focus, sustainability, and technology. And they have put together the principles and documented these, and different groups, libraries, projects, organizations can sign on to these principles. So one of the ways to, an important way to have for domain repositories to gain the trust of their community is to actually go through the certification and have it done by an outside group. That's it.
Great, thank you, Sandra, Bob, and Rebecca for those intro remarks. And so we'll move over to panel mode, and we do have a question from David Wheeler, one of our participants. So, Jeanette, is it possible to unmute Dave and have him ask his question? There he is. Dave, you might be able to unmute yourself.
Yes.
If you're still there.
So I think we should read the question. What options are available for accessing legacy data that may be HIPAA controlled when the original application may not be available?
So I guess that was a comment for the easy emulation.
Yes, apologies. That was during your portion of the presentation.
Yeah. Oh, that's okay. So yeah, with HIPAA controlled data, so it's not that the emulation accesses the data or stores the data itself. That means if it's HIPAA controlled and the owner sends it to the emulation service, as far as I know, so I only, that is what I've seen, they don't store it, they really give you the option to see the data, and then you can save it in a format and take it away from them directly. There, of course, are some steps behind that they can see more data because there has to be an administrator of the system, but that is like having an administrator on a Linux system. So if you have the access to the data and it's HIPAA control and you are the one who's allowed to use it, then it fulfills it. So it's a system. I don't think they have the official HIPAA stamp on it yet, but if they go into these cases, I'm sure they will get it quite easily because they are not storing the data. They're not touching the data at all. They are starting a software showing the data to the user.
I think also the repositories can, the different repositories can play a really important role in setting standards for removing personally identifying information from HIPAA data so that it can be shared under different regimes. I'm looking right now at the NIH DB gap policy for submission there as another interesting example. Bob or Rebecca, anything to add on that topic?
I try to stay away from data that has that kind of information in it. So. There are concerns, I will say. I work on a subcommittee of the OSTP on open science, and a number of federal agencies are concerned about how data by itself is benign, and they're happy to share it, but it might be used in combination with other data sets and end up de-anonymizing, or worse even, perhaps revealing properties of materials or whatever that are subject to are a security issue for the country. So that's another area of ongoing concern.
So the question, when I read the question, it talked about accessing the data when the original application is not available. So another good practice within repositories is to save the data in a non-proprietary mechanism after removing all the identifiable information and making sure that you can share it openly. But maintaining data sets in proprietary format is not good for the long term.
Yeah.
And I think, Sandra, in your work, you really value storing the software alongside the data. And so does it help if the software is provided in a container format, or like a notebook, like a Jupyter notebook? Does that also help with accessing different data formats? Or what are some other aspects around accessibility of data when you need access to the software to reproduce it?
So it depends more also on the science gateway, on the concepts behind the science gateways themselves. For example, Hub0 has their own repository. They have their own containers to make sure that really the software is in a version there that it can be reused and that it can be shared. A lot of science gateways do it that way, like Galaxy, you can share toolboxes. And so I think that really reproducibility has a lot of also, let's say, a little bit of little gaps there with the containerization. Containerization, I think, is a great step to start with reproducibility. But if you ever have tried to get a Docker container from Linux to Windows, you know what it means that it's not directly reproducible. So that is the other step. I still think we haven't really solved it yet. So what we do in PresQT, for example, we save a lot of the information, what kind of tools are there, but we are not, so the tools can be, if the user decides to transfer the tools with the information, the tool will be there in a Beckett zip file. But if the user decides not to transfer the tool and only the result data or input data, it's a user decision in PresQT.
Okay. Yeah, and I take your point that the containers are not a panacea. There's still a lot of details to work out there.
I love them. They solve a lot of problems, but they don't solve a problem I might have in 10 years too, you know.
So Bob had a good list of 4 R's on one of his slides: reproducibility, repeatability, replicability, and rigor. And so I want to get all of the panelists to comment on how those 4 R's impact the trustworthiness of scientific data, and maybe have some comments about how to distinguish between reproducibility and replicability, but generally how to think about those 4 R's with respect to trustworthy data. So maybe we'll start with Rebecca, then Bob, then Sandra. How about that?
So for replicating data, that's actually a way to protect it, to have multiple copies. And that is different than reproducibility, but that will ensure that the data are someplace that can be accessed. Reproducibility is probably one of the hardest ones, and in FAIR, the I and the R are the 2 that are really difficult to do. I think what's really important for reproducibility is to make sure that you have tools that can save the provenance along the way, so that you understand how the particular data you're using came to be. What were the modifications? What was used to get it to the current state? Rigor, absolutely needed for all the other, just to make sure that you're paying attention. And that goes back to what Bob said about reputation.
So let me, NIST is of course the National Metrology Institute of the United States. Metrology is the science of measurement. So these words actually have official definitions in the metrology world. Replicability or repeatability is an individual, the ability of an individual science team to get the same and consistent results day after day. Replicability is whether another science team using the same or similar equipment can get the same results. And reproducibility is a bigger concept, which is if I come to some scientific conclusion with some particular method, can that same conclusion be reached by a totally independent method? So there are different levels in the whole area of rigor, and rigor sort of is the term that sort of wraps up all of those things. We at NIST are very concerned with all of these topics because we measure things very carefully. We know what time it is to within 1 second in the age of the universe, which is pretty good, which means that we start all of our meetings at NIST exactly 5 minutes late. So these are, I think, though, really critical in terms of building a system of trust for scientific data. You have to know where you are in this space of repeatability, replicability, and reproducibility.
Yeah, and from Science Gateway point of view, also, for example, with rigor, or also from the PresQT point of view, it starts already with a fixity. It's really, if you transfer data between systems or share data, and yes, Wi-Fi gets better, internet gets better, the connections are better, but it's still, we had, for example, the situation that data was transferred to a tape station and 1 byte was moved. So the data was not readable anymore. It was really, even so the researcher did the right way and said, oh yes, I want a backup for it and I want to, it's stored. Yes, so we have to start already for rigor, also really the physical fixity of files, and really make sure that there's no defect there. And then it comes, of course, to a totally different aspect. So ScienceGate is a good opportunity to do research, share your research, and share the methods to do it. So if somebody doesn't really understand the methods, might use the method in the wrong way and have wrong conclusions out of it. So it's really important not only to describe the method and have the correct methods in the Science Gateway for our use case, but also to make sure that they're using it for the intention, and that it's not something, because it gets easier now to use some methods or to access HPC or to access workflow, computational workflow, that there is research that is not correct. So there must be a little bit of, not a little bit only, there must be a verification between the theory behind that is really in this research and the methods which I used. And if we are sure about that, and then, yeah, I repeat almost what Rebecca and Bob already said, but then the next step can be, yeah, we can repeat the method, the computational workflow. We can do it also in a different group, maybe with the same data, with the same methods. But then reproducibility is really the big concept. It's a different environment using the theory, the methods, and then for different data and different really observations and experiments. So it's from rigor is the basis to get all the other topics.
I think that leads us into a question about how we communicate the trustworthiness of the data for the consumers of the data. So we talked about standards on the data repository like Core Trust Seal, associating provenance with the data, so so you can assess its trustworthiness that way. Also, and as Sandra just mentioned, having information about the data so that the consumer of the data can use it appropriately to apply the correct scientific methods to that data. So I'm interested in additional comments from the panelists on this topic of, for the data consumers, how do we effectively communicate to them about the trustworthiness qualities of the data?
Provenance, metadata. I mean, this is an area that Rebecca and Sandra both have worked in for a very long time. You have to say what it is. And, you know, if your measurements are good to 10%, say they're good to 10%. If they're good to 1% or 0.1%, if you say what it is and you are a reputable source of data, then people will know if that data is useful for them, if it's fit for purpose. But if you don't say anything, then the consumer is, you know, consumer beware, because you don't know what you're getting and what its quality is.
Yeah, another aspect I think we have nowadays, luckily, we have really this open science movement and open sharing. I think that helps already a lot when people are contributing data, if they're allowed to. I know, of course, with HIPAA and all the different rules, there's data we cannot share the same way in an open way, at least not all the raw data. But I think it's really important. The open sharing already adds really value besides the metadata, what Bob said, and all the additional information and the provenance. And I think also really helping people to make more comments. I think we run in trustworthy data always also in the problem that there's manual work. We cannot totally take it away from the users. We can help as far as possible. So that is one of the goals of PresQT, really to add as much as possible automatically, do keyword enhancements, do the fair testing. But we are still relying on people looking onto it like, oh, is this really the field? Is this really the theory I want to connect with, for example, this data? And this manual step, even with machine learning, I think we are not at that stage yet to say, oh yeah, we can just run it through and then it does everything in the way that it's correctly, let's say, tagged and all the meta information. So I think that is still a big topic that we need to get the community the word out. Yes, it's annoying to do documentation. I say it as a programmer also. Don't like it. I know it's really, you have to do it. It's just the way to do it. So, and the same is for researchers. We try to make it easier that they can document easy, but they have to find the right way to do it, or the right words to add.
So I think the completeness of the metadata is extremely important. It's not just superficial title, a few keywords, whatever thrown in. It's very important that the metadata is complete and that it is machine actionable. It's not enough for a human to be able to read it. So I think one of the problems is that often, especially with older data, the researchers did not start out with the idea that it would be shared. So the repositories that actually have curation services, so they can go back and actually add to the completeness of the metadata, adds to the trustworthiness of a repository and the data that is stored within it.
And one thing we're trying to do at NIST in this regard is having data be born fair, so that metadata from the instrument or from the computer simulation are recorded at the time that the data are being born and are carried along for the life of that of the data. If you try to annotate it after the fact, it's not going to work. It's going to be wrong. It's going to be incomplete, and so forth. So the only thing you really can't capture now from modern instrumentation is the intent of the experimenter. Why are they doing this? But if you can capture that also at the very front end, I put my sample in for this reason, and this is what I'm looking for, then you get a full picture along with the automated metadata capture.
We've got a question in the chat from Jacob. How can we be assured that the R's are done correctly? And that's got me thinking about incentives for the scientists and the roles that the different players play. Rebecca mentioned the repositories helping to help with the completeness of the metadata, and Bob, you talked about the peer review process, including data and including the data quality there, and Sandra, you talked about tools also making it easier for the data scientists to capture all this information. So I wonder what additional thoughts do y'all have on assuring that the processes are being followed and also incentivizing it?
Well, I can talk a little bit about the incentives. Another group that I am working with is a National Academy board on improving incentives for sharing data. And there, we now have digital object identifiers for data, which are great because data can be cited and data cite. But we need to start changing the reward system and the promotion and tenure processes to recognize that producing quality data sets is difficult, but it is really important, and it will increase your profile as a researcher. So that recognition aspect, the carrot more than the stick, is a very important aspect of this.
Yeah, I think, yeah, I agree to the incentives. We really have to do something there. The other thing is the experience I make over the years now is that people who did run in the typical, let's say, typical situation, a project is going on for 3 years, no, storing of data in repositories or something. It's, on different laptops. And then the one PhD student who has the overview over everything is finished with a PhD and nobody knows anywhere where the data is. So I think this example, so I talk about it several times when I talk with people about preservation and talk to colleagues, and then they're like, yeah, okay, I will invest more time at the beginning. It is, I think we have to distribute really also the war stories. And a lot of colleagues I have really in teaching, when they hear about the PhD student situation, half of them say, it didn't happen yet to me, but you're right, it would happen to me if, if something comes now in between. So I think between the quantitative and qualitative, we have to get the word out.
I think by having different agencies require a data management plan, it's not quite a stick, but it certainly is an incentive to actually pay attention to the data. And there have been many different groups have come up with correct ways to cite data, as well as having journals that are dedicated to just data. So being able to publish a data paper also helps with as an incentive.
I think we have a next question from Alyssa.
Yeah.
So please go right ahead.
So I'm trying to ask her to unmute. Alyssa, can you unmute?
Oh yeah. Hi. I'm Alyssa from Georgetown University. I came in late, so I don't know if this has been talked about or not. We all face the same challenges. Like, it's not just about the raw data that's actually the condition around how the data is generated, or the metadata, and then the purpose. With the purpose, I think is a little researchers would be a little reluctant. Basically, they can reveal their thought and what they're trying to prove or disapprove. So that probably kind of has IP related with, but then the metadata, and then also it's very hard to enforce the capture of the metadata, with the graduate students and postdocs. So I'm just wondering if the other way would be easier to enforce the instrument vendors to, give them a set of standards and requirements that they have to build in the instruments. So when raw data gets generated, certain things are embedded, like, in the data that so when other people look at the data, at least they can actually know the condition under which the data is generated. So that way it helps with the reproducibility as well.
Oh, this is near and dear to my heart. Thank you so much, because we are working on laboratory information management systems at NIST that do metadata capture directly at the instrument. But right now we have to parse vendor proprietary formats and extract those metadata out into open formats. Another hobby horse of mine is, can we get government agencies to require, as a condition of purchase of a piece of equipment, that the vendor provides data in an open format, standard format with standard metadata fields. So I'm trying to push that agenda with the Subcommittee for Open Science and with other organizations, because I think it's really critical to this whole field of trustworthiness of data. Thank you for that question very much.
Yeah, and it's also, so my experience from bioinformatics in some fields was, oh yes, we all agree to this one format. So the vendors said, yeah, we do it in PDB. Great. Then you look in detail and they do their own PDB. So I'm totally also with you there. I would be very happy if the vendors have to follow the formats really directly how they are defined, and not do their own vendor specific additionally format and call it the same way, which makes it very confusing at the beginning, because I didn't find at the beginning then the information I looked for, and then I was like, okay, it's not really the same like the official. So I'm also totally with you there. Yes, I think vendors should be asked to provide the format in a way that it's from each vendor the same.
And I agree with both Sandra and Bob. And I know that Bob is working on a committee or a working group to make this happen. And I'm hoping he'll be successful.
Great, thanks, Alyssa, for that question. So I'm watching the clock. We've got just a couple minutes left, so I think I'll just ask our panelists if they have any concluding remarks before we wrap up. And so maybe we'll go in our original order with Sandra, then Bob, then Rebecca.
Yeah, thank you. Yeah, it was very interesting to see all the talks of Rebecca and Bob, and thank you for sharing all your thoughts on it. And yeah, what is also near to my heart is really sharing data, open science. I think that is the right way to go, also to make data more trustworthy. As soon as you share it openly, you put more emphasis on meta information or on metadata, on information, and on documentation. And I think that is a good way to go.
Everybody be as fair as possible. FAIR. I think everybody knows that acronym by now. And let's reward our good citizens in research who are data sharing. And let's put pressure on instrument vendors when you buy something, say, I need an open format.
So the Research Data Alliance is actually a good place to go to find out what is being done on all these topics globally, not just within the United States. There are lots of groups working on the building blocks to make data fair. So check it out.
Great. And we didn't get a chance to talk about the RDA COVID-19 work that's been really valuable. So that I recommend that people especially check that out. But thank you, attendees, for your participation, for your questions. Thank you very much to the panelists for joining us today. And so I think at this point, I'll turn it back over to Jeanette. I think she'll have a survey for us and some concluding remarks.
Hi, everybody. Just a few community updates before we wrap things up. This is our final presentation for the year, but that does not mean the webinars are ending. We are kicking off 2021 with a Trusted CI webinar on Monday, January 25th at 11 a.m. Eastern. Our topic is CI tokens. So Jim Basney will be pivoting to his other responsibilities really related to CI tokens. So he will be presenting on that. And then around February 2021, you should see notifications of Trusted CI accepting applications for engagements in the second half of this coming year. And so you can find more information about that at trustedci.org/application. And then to view presentations, join announcements, the announcements mailing list, submit requests to present, etc. You can visit trustedci.org/webinars, or you can email us feedback@webinars@trustedci.org. And with that, I think we will be closing our presentation. Thanks again, everyone, for attending this presentation. I will be posting, and again, our panelists, thank you very much for your presentations and your contributions. I will be posting a video of this hopefully later today. So feel free to share with your colleagues. And with that, I think I'll close things. Thanks, everybody.
Okay.
Thank you.
Bye.
Happy holidays.
Yes, indeed.